we are given a diagram. It says if the radius of the circle, so I'm going to underline the salient point here. If the radius of the circle above is equal to the chord AB, then what is the value of x? So we want to find the value of angle x, given that the radius of the circle is equal to the chord AB. Now this is the chord AB, and then we are told that the radius equals the chord AB. Now before I come to answering this question, let me just show you something. I'm not sure if you have forgotten, but I think it's going to be worthwhile if you recall this. Now this is actually a theorem in it's a theorem. It's not really like a theorem, so you don't really get too scared. It's just something you know. I'm very sure of that. Now assuming you're given a circle, let's say this is your circle. This is your circle here, something like this. Now probably this is an arc here. Maybe this arc here from here to here, let's say this is the center of the circle. So I'm going to draw this. So the angle which this arc, let's call this arc say ST. So the angle which arc ST subtends at the center of the circle, this is the angle here. Now what the theorem says is that the angle which this arc subtends at the center of the circle, and then it also subtends another one at an arc of the circle. So you can see it subtends one at the center of the circle, it also subtends another one at the arc of the circle here, on the circumference of the circle. So what the theorem says is that if the angle here is x, then the angle here is going to be 2 times x. So it's going to be twice this. So again, what the theorem says is that whenever you have an arc on the circumference of a circle, so it says that the angle which this arc subtends at the center of the circle is twice the angle which it subtends on the circumference of the circle. So you can see here. So you can see they are brothers, but the one at the center seems to be the elder brother of what you have here. I'm going to lay credence to this information in trying to solve this problem. So what we have here is we're given that the radius of the circle above is equal to the chord AB. So what I'm going to do is, if I draw a line here, so you might begin like, how am I thinking about the step I'm thinking? Now the step I took here was because I heard the word radius. So since I heard the word radius, and then the radius has to do with the chord AB, so what I thought of is that maybe I should join the center of the circle to this, because when I join the center of the circle, I'm going to see the radius here. So probably I can bring up a relationship between the chord AB and the radius. That was why I took this step. Alright, I've been told that the radius of the circle equals the chord AB. So if the radius of the circle is R and here is R, so we are told that the length AB also equals R. Now you recall that this is a triangle, this whole place here. So if this is O, so OAB is a triangle, and then this triangle here has all its sides to be equal. So this is equal to this, is also equal to, so I should use this, not this, and is also equal to this. So anytime you have a triangle such that all its sides are equal, then it's going to be an equilateral triangle. So since this is an equilateral triangle, so that implies that here the angle here must be 60 degrees, the angle here has to be 60 degrees, and then the angle here also has to be 60 degrees. Now what I'm going to do here is I'm going to project this up. Let's say we have another fine line. Just project it up to this part here. Yeah. So we have something here. Now based on information we learned here, we said that this angle here, so looking at this whole place here, you'd observe that this arc here, arc AB subtends 2 angles. Now the first angle that arc AB subtends is the one at the center. So the one at the center here is 60 degrees. You can see this is 60 60 degrees. Now how then do we obtain the one that the same arc subtends at the circumference of the circle? So based on what we have here, we said if here is 2x, then here has to be whatever you have at the center of the circle divided by 2 to get the one at this point here. So if here is 60, so the angle with its subtends at the circumference has to be 30 degrees. So now we know that. Now the thing is that how then do we find x? So again, you recall in one of the videos I explained past, I told you that anytime you have two sectors like this that share the same arc, whenever they share the same arc, you can see they share the same arc. This is the sector here, it shares this arc AB, and then this is also the same sector, they share the same arc. Anytime you have something like that, the angle which that arc subtends at the circumference of the circle, they are always equal. So if here is 30 degrees, then definitely here also has to be 30 degrees. I explained this in one of the videos I've done past, so if you don't really understand this, you can just check that out. So that's why our answer is going to be 30 degrees. So the solution to this problem is 30 degrees.